So continuing our look at the parabola and the concept of quadratic relation, here we have our parabola drawn out. And so we have that U-shaped graph. In this case, it's opening downwards. And I've labeled a few of the key parts of the parabola that we need to know. The 2 points here where it crosses the x-axis, again, those are called the zeros or roots. They're also the x-intercepts. But oftentimes with a parabola, we call them the zeros or roots, and any line or any equation beyond a line, we usually call this the same. This here, center line, is dividing our parabola in half because right here we have our vertex of the parabola. And again, we generally use HK as our label for the vertex. So the x-coordinate is h and the y-coordinate is k. And then that line that we'd put our little red mirror on, dividing the parabola in half, again, is the axis of symmetry. So if you put your little red mirror on there, you'd see that this graph would match itself on either side. So again, get familiar with those terms. We're going to use them a lot. When we look at the equations that are possible, here we have our series of equations that we could use. We have y equals ax squared plus bx plus c. Again, a is not 0, so you need an x squared in there. But the a, b, and c are just any numbers. B and c can be 0. We also use vertex form sometimes. And in the case of vertex form, there might not, and just like here, there might be a 1 for the a, so you won't see a number there, but as long as it's not 0. So we have an a, there's our h and k, so that actually relates to our vertex. We're going to talk about this in another lesson a little more. And then we also have factored form, which is one that we've worked with before when we factored these quadratics down to two binomials. So the factored form is another version of the quadratic relation. And so you have your parabola. You can recognize it by the shape. You can also recognize it if it is in an equation of any of these three forms, remembering that any one of the letters other than a could be 0. And I did miss putting in, there should be an a at the start of this one as well. So it should be y equals a times that, and that would be the common factor there. Now, moving on from that into another way to understand and look at parabolas and quadratics is with finite differences. So finite differences are when we take a table of values, and when you subtract the y values in that table of values, you can find the differences between them to determine the degree or type of relation that you have. So you could have a linear quadratic, or you could have a cubic, quartic, or so on and so forth. Or you might not have any relation whatsoever. We usually don't go beyond quadratic with these too much because it just takes a lot of effort to create them. But if the first differences between the y values are the same, then, and that's the first set of subtraction, so that when we just look at the y values, and we'll do an example here in a minute, if those values are the same, that first subtraction is the same, then those first differences mean that it is a linear equation. In the case of the second differences being the same, and this is when we'll take the results from our first differences and take the difference between those, if those are the same, then our relationship is quadratic. And we'll take a look here at a couple examples. So here I have a table of values. I got my x. I'm just using -3 to 3. Good set of numbers whenever you're making a table of values is to use something like -3 to 3. It'll give you a good view of what's going on. Also, make sure you do them in numerical order. Okay, don't put like -3, +3, -2, +2, or something like that. Keep them in order. Yes, use negatives because it could make a difference in certain types of graphs. And keeping them surrounding 0 is usually where we're looking, so it's usually the best place to make use of them. The table of values here. Now, to find our first differences, I'm going to make another column. And how people lay this out might be different. Some people don't use the column method. I like using the column method. So that's my first set of differences here. And so I'm going to take the difference from each one. Now, there is no number to compare with the 12, so I block off the first box here. And look at the difference between 7 and 12. So 7 minus 12, okay? So this is 7 minus 12 that we're doing in this first box. And so that's going to give us a result of -5. And then we're going to go through each successive pair like this. So 4 minus 7. So you're always subtracting the previous y value. 4 minus 7, that's going to equal -3. And if we do this one more time, 3 minus 4 is going to equal -1. And now we're doing 4 minus 3 to get 1. 7 minus 4 gets us 3. And 12 minus 7 is going to get us 5. So -5, -3, -1, 1, 3, 5 are our results there. Those are our first differences. They're not the same, so this is not a linear equation. So we'll try it one more time and try and create the second differences. So we're not going to have anything to subtract again in this first box, and again we're not going to have anything to subtract in the second box because we're comparing the differences between these numbers, -5 to -3 and so on. So -3 minus -5 is going to get us +2. -1 minus -3 is going to get us +2. 1 minus -1 is going to get us +2. 7 minus 4 is going to copying the same numbers here. 3 minus 1, let's clean that up here. 3 minus 1 is going to get us +2. And 5 minus 3 is going to get us +2. So in each case, we have a +2. Thus, because all those second differences are the same, this is a quadratic relation. When we graph this, we will get a parabola. Now, if we switch over to the second example here, and take a look. Some of you might already be able to see it right away. But if we take our first differences, again, blocking out our first spot, 1 minus 0, the difference between that is 1. And then 1 minus 2, the difference between that is 1. 1, 1, 1, 1. We got a difference of 1 all the way down. This is a linear relation. This also happens to be the slope. So in the case of the first difference is the slope. Note this is not the slope of the equation here. So our second differences do not relate to the slope itself. We don't take the slope of a parabola because the slope is a linear measurement. So we have a linear relation if the first difference is the same. If the second difference is the same, it's a quadratic relation. And in the case where neither the first nor the second are the same, then we would have a non-linear or quadratic relation. We just say that it's neither. And then just a little a bit on filling in a table of values. Hopefully you guys are pretty confident with this, but just for some review. If you're asked to plot y equals negative 4x squared plus 3, when we create a table of values, we make our t-chart. And then again, highly recommended use the numbers negative 3 to positive 3, unless the situation doesn't call for negatives. Like if it was something like, how long has something been a car been driving? Well, you wouldn't drive negative time. So you'd use just positive numbers. But in most cases, if you're just given an equation, negative 3 to positive 3 is usually your best set of numbers. And now this is going to have a little hiccup that people often get concerned about, but that's why I picked this set. So if we actually tabulate all the numbers here, we would do the y equals negative 4 times negative 3 squared plus 3. And then y equals negative 4 times negative 2 squared plus 3. And negative 4 times negative 1 squared plus 3. And negative 4 times 0 squared plus 3. And negative 4 times 1 squared plus 3. Negative 4 times 2 squared plus 3. And negative 4 times 3 squared plus 3. So we calculate each of these. All we're doing each time is replacing the x value. Notice I put it in brackets with the 3. And the reason why I put it in brackets is because if you don't put it in brackets, you try and type this in your calculator. 4 times minus 3 squared, it's going to square the 3 and then put a negative sign in front of it. It'll give you a result of negative 9. Negative 3 times negative 3 is positive 9. You need to use the brackets here, okay? Negative 3 times negative 3 is equal to positive 9. If you don't do that, when you square, it's going to do negative. So this here is not the same as this. This step here, I'll move that up a bit. This step here is not the same as this. This here answers negative 9. You need to do the whole negative 3 squared to get positive 9. So you got to make sure that you put it in brackets. Okay, if you want this situation here, then you have to do this. Okay, this is not the same. So when we calculate those, put those in your calculators or whatnot. If you don't have that, your phone or computer, and tabulate all those, you're going to get negative 33, negative 13, negative 1, 3, negative 1, negative 13, and negative 33. Now, we take each of these pairs of numbers, the x and y, and we can plot them on the graph. Now, this is what concerns a lot of people, is right away, there is no negative 33 on the graph, because right now I made mine where every dot was 2. What do? I can't graph it. That's okay. We'll just ignore that completely. Whatever doesn't fit, we'll ignore. Now, 12 and negative 13, I can just about plot that. Or sorry, negative 2 and negative 13. Negative 2 and negative 13 is just about right here on my grid. And negative 1 and negative 1, that is going to be right here. 0 and 3 is right here. And then 1 and negative 1 and 2 and negative 13. So we got a graph about like this. Now, do not use a ruler, okay? There is no straight line between these 2 points. We don't use a ruler for these. We try our best to make a smooth curve between the points. So in this case here, we have a very narrow and skinny parabola that is opening downward. All right, the vertex here is at 0 and 3. And it's a skinny parabola opening downward. So when we're making our table of values, Use -3 to 3 is your standard set of numbers you'd want to use. And then you plot what you can. There will be occasions where, yes, you'll get really big numbers. You may have to change your scale. In my case here, I felt this was the best. It got me some of the points. Otherwise, I would be really tight trying to fit in that 33. So, some questions and things that you can look at is that you can read the examples in the textbook sections 4.1 and 4.2. If you have your textbook, great. If you don't, take a look at the digital copies that I've shared with you. So 4.1, you can check out questions number 1 and 2, and then 4.2, questions number 1, 3, 4, 5, 6, and 9. In the next video, I will do a quick little assist on how to do some graphing on the computer. So if you have access to your computer, you can use some online graphing tools or use the Microsoft Excel spreadsheets to create table of values and graph those. And I'll show you how to do that in the next video, which might help with some of the questions, especially in 4.1 and 4.2.